So in this class we will discuss another problem of analyzing a cantilever truss using method of joints. So this is a cantilever truss. This is a cantilever truss because one end is fixed or restrained and the other end is free. So that end A is free end. There is no support. Whereas at the ends D and E you have a restrained condition. So there are, you can observe here, load is acting at this free joint A. You can see that there are 5 joints here, A, B, C, D, E, and there are 6 members, A, B, AC, BC, BD, CD, and CE. So we have to find out the forces, internal forces developed due to this 200 kN external force in all the members. So as already told, the forces may be either tension or compressive in nature in all the members. So totally we have 6 members. 6 members means at a joint maximum we can find out 2 unknown forces using the 2 equilibrium equations, sigma fx0, sigma fy0. So there are 5 joints here, there are 6 members. Now if you observe the truss here, you need not find the support reaction in the case of a cantilever truss. Whereas in the case of a simply supported truss, first step is to find the reactions using equilibrium equations. Here it is not required because we can move from the free end. So you can choose the first joint as the free end joint, and from there onwards you can move. So here, if I take joint A here, I can easily find out the forces in the members A, B and AC which are meeting at joint A. Only 2 unknown forces are there. So first joint I can take A, then we can move towards B here. When you move towards B, there are 3 members connecting at B, AB, BC and BD, out of which AB force is already known. So therefore unknown forces in BC and BD can be found out, 2 forces. Next, coming to joint C, there are 4 members meeting at joint C, CA, CB, CD and CE. Out of 4 members, we have found out already by applying the equations at A and B. We already know the forces in CA and CB. So only unknown forces will be in members CD and CE. So by analyzing only 3 joints A, B and C, you can find out the forces in all the 6 members of the given truss. So first we can take up joint A here. So always you take the free joint first in the case of a cantilever truss. So at joint A you have a downward force of 200 kN that you have to take, and at joint A you have 2 members meeting at joint A, that is AC and AB. Initially we will not be knowing what type of force is present in that or develops in that. So we will assume that tensile force develops in both the members AB and AC. Tension means away from joint A. So since we are considering joint A, we have to choose the force. Tension force means it should act away from the joint A. So both in AB and AC, I will take the force acting away from joint A. That means FAC, it is away, and FAB is also away from joint A. So that means there are 3 forces here, 200, FAC and FAB. This FAB you have to resolve. You have to resolve because you have to apply equilibrium equations. This FAB force we have to resolve. Since you know this angle as 26.6 degrees, which you can compute from the geometry, so this angle will be BC divided by this AC. So BC is that is tan inverse of BC by AC. BC is 2 meter, AC is 4 meter. That is tan inverse of 2 by 4, which is tan inverse of 0.5, which is nothing but 26.6 degrees. So since this angle is 26.6 degrees, once you know the angle and the force, you can resolve it. Now, this is the resolution. If you resolve this, horizontal component will be like this, vertical component will be like this. Now, apply the equations of equilibrium. Sigma fx0 treating towards right positive. So if you observe this FAC is acting towards left, so negative. So minus FAC, and this is also acting towards left, therefore minus FAB cos 26.6 degree is equal to 0. That is your equation 1. You cannot solve this because there are 2 unknowns. Now the second equation is sigma fy0, upward forces positive. Here 200 is acting downwards, therefore minus 200, and this force is also negative. minus FAB sin 26.6 degree is equal to 0. So from this you can solve for FAB. You are going to get minus 446.7 kilonewton. Since it is negative, the force is compression force C. So force in the member AB is this much. It is compressive in nature. Now this value you have to substitute in this equation 1 to get the value of FAC. So FAC will be, so if you substitute this, if you bring to FAC, if you bring to that side, it becomes positive. This will be minus FAB. So minus into minus 446.7 into cos 26.6. If you simplify, you will get positive value of 400 Newton. So that is tension force. So the force in the member AC is tension force, whereas the force in the member AB is compression force. Now that means by taking joint A, we have found out two unknown forces in the members AB and AC. Now next joint is come to joint B. So we write down the free body diagram of joint B here. So joint B, if you take, there are 1, 2, 3. Three members are meeting at joint B, BA, BC and BD. So we know the force in the member AB. So FAB we have found out that it is compressive force of 446.7. Now compressive force means towards the joint. We have to take towards the joint that force is acting 446.7. This arrow will be like this towards the joint, and as well this angle will be 26.6 degree. Now we don't know the forces in BC and BD. Those two forces we have to find out. Initially we will assume that they are tensile forces. Tensile forces means we have to assume away from B, like this and like this. So this is FBD, this is FBC. Now you have to apply equilibrium equation for this free body diagram of joint B. Before that you resolve this. So this force is like this, 446.7. Force is like this, and this angle we know that it is 26.6 degrees. Now if you resolve that, horizontal component will be this, vertical component will be this. So cos and sin respectively. Now apply the equilibrium equation. First equation, sigma fx 0. So sigma fx 0 is applied towards right positive, left negative. So this FBD is acting towards left. So minus FBD. And if you resolve this is also acting towards left. Minus 446.7 cos 26.6 degree is equal to 0. So from this you can easily calculate FBD, which is negative, minus 417.3 kilonewton. So this is compressive force. It is compressive force. Next is sigma Fy is equal to 0, upward positive, downward negative. So you can see here FBC is positive because it is acting upward, whereas this is downward, minus 446.7 into sin 26.6 degree is equal to 0. So if you solve this, you will get FBC as 200 Newton, which is positive. That means tension force. So by analyzing the joint B, equilibrium of joint B, we got forces in BD as 417.3 Newton compression and force in BC as 200 Newton tension. So totally we got now in 4 members. Now next joint is C. You come to C, wherein as I already told, you have 4 members at C. CB, CE, CV, CB and CA. Like this. This is the free body diagram of joint C. So here CA, already you know the value. AC or CA is same. 400 Newton tension. This tension means you have to take away from C. So that means whichever joint you are considering, from that joint, if it is tension, you have to take away from the joint as the arrow, tension force. If it is compression, towards the joint, you have to take. Now it is tension, therefore you have to take away. Similarly, in BC, you have tension force, away from C, you have to take like this, 200. And let us assume the forces in the members CE and CD as FCE and FCD tension. Tension means once again, you have to take away from C, you have to take away from C like this. And as usual, this angle is 26.6 degrees both. Now this is the free body diagram of joint C. We have to apply, we have to find these two forces now. So we have to apply two equilibrium equations now. As usual, use sigma fx is equal to 0 here. Sigma fx is equal to 0 if you use for this is plus 400. See here. Because towards right positive, plus 400. This if you resolve minus FCE, this becomes minus FCE cos 26.6 degrees, and this also minus FCD cos 26.6 degrees is equal to 0. So we have to resolve these two now. Okay, I hope you know how to resolve this. Next, sigma Fy is equal to 0, upward positive, downward negative. Here, this 200 is acting downwards, so minus 200. Then if you resolve this, vertical component will be upwards, therefore plus FCE sin 26.6 degrees. If you resolve this, vertical component will be downward, so it is minus FCD sin 26.6 degrees is equal to 0. Now we have got two equations like this. So two unknowns, two equations you can easily solve. What I have done is I have just solved like this. I have taken equation 2 and I have substituted for cos 26.6 degrees, which is nothing but 0.894. The FCE into 0.894. This I have taken that side, plus FCD into 0.894 is equal to 400. Now dividing both LHS and RHS by 0.894, you got here as FCE, here as FCD, and here this divided by 400 divided by 0.894 is 447.4. So you call this as equation 4. Similarly, equation 3 can be written as sin 26.6 degrees is nothing but 0.448. So this is FC into 0.448 minus FCD into 0.448. This 200 if you bring to RHS, it becomes plus 200. Minus becomes plus. So dividing this once again by 0.448, both LHS and RHS, you get this equation FCE minus FCD is equal to 200 divided by 0.448 is nothing but 446.4. Now these two equations, so these two equations have been reduced to this form. So just if you add 4 and 5, this FCD will get cancelled in the LHS. And this plus this will be 893.8. So 2 FCE is equal to this, therefore FC is equal to 446.9 kN. Substitute that which is positive, therefore the force is tension in CE. Similarly, you substitute that value of FCE in one of the equations, either 4 or 5, you will get the another value of CD. Of course, here you are getting 0.5 kN. Of course, almost it is negligible. We can take it as 0 also. It is a dummy member. So any member which carries 0 force is called as a dummy member. Those members are required for stability of the truss. It is not required to carry the load. But to have the stability of the structure, sometimes we have to provide some additional members which don't carry any force. So they are called as dummy members. So here FCD force almost it is negligible, 0.5 compared to other member forces. There is no force in member FCD, or it is 0.5 kN, very small value. So finally we got the forces in all the 6 members. So by considering joint A, we got the forces in AB and AC. By considering joint B, we got the forces in BD and BC. By considering joint C, we got the forces in CE and CD. Finally, you can put all this in the form of a tabular column. So like this I have explained in the last problem. Remember, forces in kilonewton and nature. So like this, you can have a tabular column. If they ask you to tabulate the values, you just write like this. For example, member AB is compression. You have to write AB here. So it is compression here, nature, value is 446.7. Magnitude only we have to write, kilonewton. Similarly, AC is tension 400. So 400 tension force. Like this, you can tabulate all the other 4 values also. So in the case of a cantilever truss, you need not find the reactions. You can start from the free end. So free end is this end A. So you can start from the free end, the method of joints, and apply the equations of equilibrium, 2 equations of equilibrium, and get the unknown forces. Thank you.